Asking and exploring, friends. How are you? About 2,400 years ago, 2,400 years back, in the Greek city of Abdera, there lived a philosopher named Democritus. Abdera, friends, was a region of Greece whose people were famous for their jokes. As you know, sometimes certain places or nations become associated with humor, and people begin to smile just by hearing their name even before hearing the rest of the story. Something similar was the case with the people of Abdera in ancient Greece. Perhaps that is why, friends, if you look at statues of Democritus today, in most of them his face appears cheerful and smiling in a humorous way. Friends, Democritus of Abdera did not get along with many philosophers of his time, including great names such as Plato. Because of his sharp and sarcastic remarks, many philosophers disliked him. However, friends, this unpopular philosopher observed some facts about 2,400 years ago and reached an extraordinary conclusion. At that time, there was an ongoing debate. Everything in the world, this matter that exists, what is it made of? There must be some fundamental thing from which everything is made. What is the smallest unit? Most philosophers of that time, including Plato, followed the older Greek philosophy which said that everything in the world is made of four elements: fire, water, air, and earth. For many centuries, philosophers and educated people believed that everything was composed of these four elements. According to this idea, humans were made from earth and the conditions of life came from water. But Democritus observed something different. He noticed that when a thing is cut or broken into smaller and smaller pieces, eventually it reaches a stage where it cannot be cut or broken any further. And that final piece is not necessarily water, earth, fire, or air. That smallest particle still resembles the original substance. For example, if a fruit is cut, even the smallest piece tastes sweet. If a stone is broken, the smallest visible piece still looks like stone. Whatever object he broke or cut, its smallest piece still resembled the original material. Observing this fact, Democritus said that if we keep cutting matter into smaller and smaller pieces, eventually we will reach a stage where it cannot be divided any further. Based on this observation, he proposed a hypothesis. Everything is not made from fire, water, air, or earth, but from extremely tiny particles that cannot be divided further. These indivisible particles were called atomos in Greek, meaning indivisible. This idea later became known as atomism. The word a meant not, and tomos meant cut or divide. So Democritus named this invisible particle atomos. He said that the smallest particle of every substance is an atomos, and everything in the universe is made of these particles. Moreover, the atomos of each substance is different from others. That is why different things exist. He even proposed a simple model. He suggested that soft and edible things have soft atoms, while stones or metals have hard atoms with particular shapes. He even drew rough sketches and showed them to his students, explaining that the atom of one substance might look like this and another like that. And remember, friends, this was being discussed almost 2,500 years ago. He also said that the easier it is to break something, the more space there is between its atoms, which allows it to be broken more easily. Now, friends, this was a very simple but truly genius idea. In science, when conclusions are drawn from facts, observations, and repeated experiments, their explanation is called a theory. So Democritus was the first person who essentially proposed the atomic theory. At that time, it could also be called a hypothesis because it took a long time to be proven properly. However, many of the most intelligent people of that era rejected his idea. Among them was Plato, who disliked Democritus so much that he even suggested burning Democritus's books. For the next 2,200 years, Plato's view continued to dominate, and Democritus's idea was largely ignored. His theory survived mainly in Greek texts that were translated during the Abbasid era. Then in 1808, the English chemist John Dalton conducted experiments with gases in his laboratory and observed an important fact. He noticed that when gases and chemical compounds react with each other, the total weight of each element remains the same. This meant that each element must be made of tiny particles with a fixed mass. When substances mix, their particles simply combine without changing their own mass. After many repeated experiments with gases and chemicals, Dalton refined Democritus's model. He proposed that everything in the world is made of elements, and each element consists of extremely small particles called atoms. He also stated that atoms cannot be created or destroyed, and that chemical reactions only
rearrange them. Later discoveries showed that atoms themselves contain smaller particles such as electron, proton, and neutron. Even though atoms can be split, the basic idea that matter is made of atoms became stronger over time. Today, we can even observe atoms using powerful electron microscopes, but the atomic theory had already been accepted before that because it successfully explained chemical reactions and many discoveries in physics. Friends, in science, an explanation based on facts and repeatedly verified by experiments is called a theory. A scientific theory is not merely a guess, it explains scientific laws and models. Now let's look at another example. Until 1912, scientists believed that the structure of Earth had always been the same since its formation about 4.5 billion years ago. They thought the 7 continents and oceans had always existed in their current positions. But in 1912, the German geophysicist Alfred Wegener observed some surprising facts and proposed the theory of continental drift. By studying the shapes of continents such as Africa and South America, and the geological similarities between distant regions, he suggested that these continents were once joined together and later drifted apart. If you look carefully at the map of the world, you might also feel that these continents once fit together like pieces of a puzzle. In the second phase, Alfred Wegener began searching for crucial evidence from these places, trying to determine whether what he believed was actually true or merely a coincidence that appeared like a historical reality to him. Poor Alfred Wegener, my friends, spent his entire life moving through extreme cold, intense heat, humidity and rain, enduring all kinds of weather, running from one continent to another, from one mountain to another, from one ocean to the next. This constant struggle and research paid off, and he found a great deal of evidence. For example, regarding Africa and America once being connected, he discovered very strong proof. One was that they looked like 2 pieces of the same puzzle. Then he found fossils of the same long-tailed reptile in both places. These fossils belonged to a reptile called Mesosaurus, which lived about 200 to 300 million years ago. Mesosaurus was about 3.5 feet long, a crocodile-like reptile that crawled on 2 legs and lived in fresh water. This reptile is now extinct, but the key point that helped Alfred was that it lived in fresh water. The fossils of Mesosaurus were found in places that were either near fresh water or within freshwater environments. Moreover, the structure of its body also clearly indicated that it was a freshwater animal. But the surprising thing was that the same animal's fossils were found by Alfred Wegener not only in Africa but also 4,000 kilometers away, across the Atlantic Ocean in eastern America. These fossils were just as old as those found in Africa, around 200 to 300 million years old. Now, my fellows, you might be wondering how we determine the age of such fossils or skeletons. The answer to that will be explained in upcoming evolution vlogs, where you will clearly learn what carbon dating is, how fossil ages are determined, and what other methods exist besides carbon dating. For now, let's complete this story. So, friends, when fossils of the same animal of the same age were found in Western Africa and Eastern America, one thing became clear: this crocodile-like freshwater animal could not have crossed 4,000 kilometers of salty ocean water to reach another continent. Reptiles may survive in freshwater for some time, but the ocean is not their habitat. You see crocodiles in rivers, not in oceans, so there was no chance of it swimming across such a vast distance. Therefore, the only logical possibility was that these 2 places were once close to each other or even connected. In that case, Mesosaurus could have lived across that entire region, become extinct there, and left its fossils behind in both places, which are now thousands of kilometers apart. Wegener also studied the mountain ranges of America and Europe, as you can see on screen. He observed that the rocks on both sides were astonishingly similar. Even the fossils later found there were of the same type and about 200 to 300 million years old. This suggested that these regions must have been connected in the distant past. Similarly, the rocks of Africa and America, whose shapes look like matching pieces of a jigsaw puzzle, were also proven to be similar. So, friends, after observing the similarity in rock structures, fossil records, and the puzzle-like fit of continents, the explanation that Alfred Wegener presented is known as the continental drift theory. In this theory, he proposed that all the land on Earth was once joined together as a single massive continent. Over time, it slowly drifted apart into separate continents, and they are still moving today. Wegener named this supercontinent Pangaea, meaning all Earth. He also predicted that if his theory were correct, then similar evidence should be found in other parts of the world that are now far apart but were once connected in Pangaea. This puzzle would eventually be solved. It was a remarkable theory and prediction that truly shook the scientific community. The idea was so extraordinary that, although Wegener had fulfilled many requirements of a scientific theory, he faced intense criticism as soon as he presented it. He already knew this would happen, because scientific communities often reject new theories very strongly, sometimes even more strictly than religious groups, due to competition over who makes the best and earliest discoveries or models. That is why, until a discovery or theory fully proves itself, it is not accepted in the scientific community, where a great deal of rigidity is shown. The only difference is that once something is proven in science, everyone eventually accepts it. Of a scientific theory, he faced intense criticism as soon as he presented it. He already knew this would happen, because scientific communities often reject new theories very strongly, sometimes even more strictly than religious groups, due to competition over who makes the best and earliest discoveries or models. That is why, until a discovery or theory fully proves itself, it is not accepted in the scientific community, where a great deal of rigidity is shown. The only difference is that once something is proven in science, everyone eventually accepts it. People often try to take credit, saying that this part was mine, or that part was mine. Similarly, Alfred Wegener's continental drift theory was also strongly rejected in the beginning. It was mocked and ridiculed. Scientists criticized it heavily, saying, "What kind of theory is this? How can entire continents move? This is nonsense." Wegener kept hearing such criticism and passed away before his theory became widely accepted. However, later on, evidence supporting his theory began to emerge within the scientific community. Here's an interesting point. During World War II, specifically on August 6 and 9, 1945, atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki. This marked the beginning of the atomic age. Countries like United States and Russia started developing nuclear weapons and conducting secret tests to detect where such secret nuclear tests were happening. Powerful countries installed seismometers in various hidden locations across the Earth. These devices could detect ground vibrations caused by nuclear explosions. Interestingly, instead of just detecting nuclear tests, these seismometers led to a major scientific discovery. They also began detecting earthquakes and the movement of Earth's plates. Since they recorded any kind of ground movement, scientists started receiving data about the shifting of Earth's layers. Eventually, it was confirmed that Earth's landmass sits on several moving plates. By the time this discovery was fully accepted, about 3 decades had passed since Wegener's death. These moving plates were named tectonic plates. Further visible evidence also supported this theory. For example, the Great Rift Valley in Africa is a major proof where the Somali and Nubian plates are drifting apart. This region stretches from Ethiopia through Kenya to Mozambique and contains large rift lakes formed over millions of years. With modern tools like satellites and magnetic field measurements, the drifting of continents is now undeniable. This understanding also helps scientists predict earthquakes, tsunamis, and mountain formation. Wegener's theory is now accepted, with a slight correction. While he correctly proposed that continents drift and were once joined as a single landmass, he could not correctly explain why they move. He thought it was due to Earth's rotation, which was incorrect. Today, we know that continental drift occurs due to tectonic plate movement, a concept known as plate tectonics. Wegener's proposed supercontinent, Pangaea, is now a well-established reality. Scientists also believe that multiple supercontinents have formed and broken apart over Earth's 4.5 billion-year history, and this process continues. For example, the collision of the Indian plate with the Eurasian plate formed the Himalayas. In the future, another mountain range may form between Africa and Europe. The Mediterranean Sea may eventually disappear as these plates move closer, about an inch per year, and millions of years later, a massive mountain range could form there. All of this understanding comes from a scientific theory. Despite being called a theory, continental drift is a well-supported scientific explanation based on evidence. Similarly, Isaac Newton's theory of gravity states that every object attracts another based on mass and distance. Later, Albert Einstein refined this with his theory of relativity, explaining gravity as the curvature of space-time. A major confirmation of Newton's theory came with the discovery of Neptune. It wasn't directly visible, but irregularities in Uranus's orbit suggested the presence of another massive object, leading to Neptune's discovery in 1846. Today, systems like Global Positioning System rely heavily on Einstein's relativity to provide accurate location data. All these examples show that a scientific theory is not a guess or imagination, it is a well-tested explanation based on evidence, capable of making accurate predictions. For instance, the idea that Earth revolves around the Sun is known as the heliocentric theory. Before that, the geocentric theory, supported by Ptolemy, claimed Earth was the center of the universe. However, it failed to accurately predict planetary motion. Later, Nicholas Copernicus proposed the heliocentric model, where the Sun is at the center. This model successfully explained planetary movements and allowed accurate predictions. That's why modern space missions to the Moon and Mars rely on these accurate predictions to reach the correct positions at the right time. As a result, the geocentric theory was rejected, while the heliocentric theory was accepted as a scientific theory. This means that the idea of the Sun being at the center is considered a theory, a scientific theory, and it is accepted because it is a practical reality. So, friends, a theory is the explanation of facts and scientific laws.
It is neither a scientist's dream nor imagination. So, just like atomic theory, continental drift theory, gravitational theory, the theory of general relativity, and the heliocentric theory, Charles Darwin's theory of evolution by natural selection is also a scientific theory. And here, friends, you should definitely ask, what evidence did Darwin present for his theory of evolution by natural selection? What predictions did he make? After 160 years, is there even a single piece of evidence that disproves Darwin's theory? Did humans really evolve from monkeys? We will discuss all of this in the next vlog. Make sure to watch it.